Good evening, ma. In continuity of the previous class, we were discussing and we are trying to derive the relation for the blade height, right? And this blade height is given in terms of volume of a flow. And how this volume of a flow is mentioned, and it is given in terms of flow area multiplied by the velocity of a flow, right? Flow area means the flow will be occupying some area and to certain height, and therefore it is given in terms of pi d suffix m into h into multiplied by that of velocity of a flow. Yes, and what is this d suffix m? It is a mean blade velocity. So mean blade diameter, and vf is velocity of a flow, and from the h stands for blade height. If I am given the volume of a flow, I can easily find the blade height looking at the pi and the mean diameter and the velocity of a flow, right? And in connectivity to that of the volume of a flow, even I can derive the relation for mass flow rate. Is there any need to find out the mass flow rate? Where you are going to come across this mass flow rate? Tell me, ma. If you want to find out work done, or if you want to find out the power developed, you need to know the value of mass flow rate. Okay, if it is given in the problem statement, you can find the other unknown data. If it is not given, then you have to find out with the help of the mean diameter, height of a blade, and velocity of a flow in terms of dryness fraction and the specific volume of steam at that particular given cross section, right? If this mass flow rate is also not given and h is also not given, then how to find out the value of h? If the volume of the flow is known to you, then you can find the blade height. If you know the blade height, then automatically you can find out the value of mass flow rate, right? Am I clear? Now, we try to find out the relation for mean blade diameter. How it is being expressed. If diameter of a blade is given directly, how to calculate this mean diameter, right? dm equals to d plus h. What is this d? D is nothing but diameter of wheel. All the time the mean diameter may or may not be given. So if the diameter of the wheel is given, how to find the value of mean diameter? With the help of d and h. Yes. Now h is blade height as we discussed earlier. Right? Now we have a standard value for this value of for any of a particular design, right? This h by d is a constant value. If you remember this constant value, and if sometimes if it is given in the problem statement, you can find the value of mean diameter, right? And generally we represent h by d as a constant. And how we represent a constant? With the letter k. That is, h by d can be written as k, and that k value is given as 1 by 12. What is the value of k here now? K equals to 1 by 12. Is this clear now? Now, you remember this value. H by D relation is specified as a k, and that k value is a constant, and that constant is nothing but 1 by 12. Right? Now we will look at the another term. Steam flow rate in terms of k. In terms of k. How to find out the steam flow rate in terms of k? Since m equals to pi into dm into h into Vf divided by x multiplied by specific volume. Yes, do we remember this? Yes. Now in place of dm, can I write the value of d plus h? Yes, pi into d plus h into h multiplied by Vf divided by x into specific volume. Now m equals to pi into d plus k suffix k into d. K into d. Yes, I am trying to shuffle the terms, that's it. X into v suffix s, that equals to pi into 1 plus k d square into v suffix f divided by x into v suffix s. Is this clear? If I want to express in terms of k, the mass flow rate, how to substitute it? Just I replace the term for dm equals to d plus h, and I have relation h by d equals to k. In place of h, I have written the value of k into d. Yes, from the relation you may get confusion and you may think of how did we get the relation here kd in place of h. Since we know that h by d equals to k, can I replace h equals to k into d? The same thing I have done there, nothing more than that, right? Just please think and let me know whether you understood this conversion or not. Yes, now we will look at one specific condition here. What is that? The condition is like the steam of which is flowing through the blade annulus is incomplete. Incomplete means not full. All the time it may not be full. At this condition, what would be the relation for the mass flow rate? What is the condition here? The steam flow through the blade nozzle. No, we use this term through the nozzle, therefore we will call it as annulus. Annulus is incomplete. Is incomplete, that is not full. Then the relation would be m equals to z multiplied by ph in terms of vf divided by x into v suffix s in the specific volume. Now we'll see what is the z and p stands for. Z is the number of blades covered by nozzles. And what is this P? P represents pitch of the blades in meters. Yes, this is the expression that we have. You may ask me like, ma'am, you have derived for the incomplete. Then what would be the relation when it is complete? Case 2. What is the case? Nozzle coverage of the blade is complete. Then Z into P equals to Z into P equals to circumference at the mean blade diameter. It is nothing but pi into dm, right? That's what we have discussed earlier. Therefore, in this usual cases, this is the same as usual in the reaction turbine, what we have learned earlier, right? In place of Zp, we can represent it as a pi into d suffix m, where the d suffix m is the mean diameter. Just once again, shall we recap? We have tried to find out the relation for the mass flow rate in terms of K. K is the constant given for the ratio of height and the diameter, blade height and the diameter of a wheel, right? And we have derived the relation. But in practical, when coming to the real picture, always the steam flow through this blade annulus may be full or may not be full. That means it may be complete or incomplete. We will consider these as the case 1 and case 2, right? If we consider this as a case 1, for an incomplete flow, the relation of the mass flow rate is given in terms of Z into P multiplied by H into Vf x into specific volume V suffix S. The same relation. But how it is being represented? It is represented in terms of blade covered, number of blades covered by the nozzle to the pitch of the blades. And in the second case is that when the blade is complete, the nozzle coverage of this blade is completely filled, then the ratio of this Zp, in place of Zp, we take the value of pi into d suffix m. It is the circumference of the mean blade diameter, right? Circumference is nothing but the area multiplied by area, right? The entire circumference, it is like circumference is given as the a circle is given as the pi into d suffix em, right? Am I clear with this? And now we can end this, and we'll try to derive the condition for maximum efficiency of a reaction turbine in the next class, right? Thank you. Just try to recollect it and try to get what would be the condition for the maximum efficiency of any of a reaction turbine. Just think for a minute.